In this course, students will be able to explain the linear static assumptions, demonstrate the derivation of the element stiffness matrix using both the direct method as well as the potential energy approach. We'll discuss the concepts of the global stiffness matrix and nodal degrees of freedom and relate those to boundary condition definitions that analysts would use to define boundary conditions. We're also going to be relating element order to shape functions. So you may have heard of terms such as linear elements or quadratic elements, and shape functions are the underlying theoretical concept behind those terms. Similarly, you may have heard of underintegrated or fully integrated elements, and we will explain numerical integration as it relates to the finite element method. Throughout the course, students will construct, execute, and interpret a finite element model so that throughout the course we'll be relating these theoretical concepts to modeling choices and modeling decisions that are necessary to use these tools. The courses are accessed through Ohio State University's Carmen Canvas learning management system. Through a web browser, you would just log in using your Ohio State credentials that you will receive upon registering for the course. And on your landing page, you will see your Finite Element Principles course. The course starts with a welcome module which orients students to the learning management system as well as online learning. Student support services are provided along with accessibility and additional resources that students would find helpful. We also talk about online learning. These courses are offered in an asynchronous format, which allows users to access the course materials at any place at any time. This was done in order to increase the flexibility as much as possible for busy working professionals. However, you're not on your own. You will be going through the course with other students, and this is an instructor-led course, and there will be communication throughout the course. Each module layout will begin with an introduction, a learning guide where all activities and assignments for the module can be accessed from that page, the course content, and the assignments, which are quizzes, homework assignments, and the project assignment that runs the length of the course. We then talk about expectations for the course, again reiterating that this is not a software training class, but rather that we're talking about the theoretical concepts behind the finite element method. And we talk about expectations for assignments. For each module, students will have the opportunity to respond to questions in a discussion board, which will enable them to communicate with the instructor as well as with other students. There will also be multiple choice quizzes, which students can work through simple problems in order to check their understanding of concepts throughout the class. In addition, there will be homework assignments in which students will solve problems using the finite element method concepts presented in that module of the class. Throughout the course, students will plan, build, and execute a finite element model using the concepts presented in the class. We'll start with a project proposal, building an initial model, experimenting with that model, and finally submitting a report and making overall engineering judgments about the problem that students have chosen to work on. There will be grading throughout the class in order to provide feedback and to keep students' projects properly scoped and on track throughout the class. In order to receive the certificate of completion, students must complete each assignment. Upon completion of each course, 4 CEUs will be earned by the students. So these courses can count for your professional development requirements. In our next video, let's take a look at modules 1 and 2, looking at the theoretical videos as well as the application videos so that you can get a better idea of the course.